this video, we'll solve two application problems that involve slope as average rate of change. So, the slope as rate of change is still defined by the same formula because it represents the change in y over the change in x. Now, the average rate of change of a function would be represented by f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, and it will represent the average rate of change of the quantity on top, which is the dependent variable, per unit of the independent variable from the bottom. So I have two examples that I want to solve with you. So the first example, let's take a look at the first one. The bar graph shows that as costs change over the decades, Americans devoted less of their budget to groceries and more to healthcare. And we have here a table. The best thing when you have a graph is to actually read what's the x-axis, it's time, right, and it's the years, and when the food was spent and the money was spent for healthcare. The y-axis is percentage of total spending. So basically in 1950, the percentage of total spending was 22%. In 2010 was 7%, while in 2010, 16% was spent on healthcare. So let's take a look at the problem and see what we have to do. So in exercises 25 and 26, find the linear function. When I hear linear function, I think of f of x equals mx plus b. This is the form of a linear function. In slope-intercept form, we put it in slope-intercept form, that models the given description. Each function should model the percentage of total spending p of x by Americans x years after 1950. So basically, they don't want me to use f of x, they want me to use p of x. So, 25. In 1950, Americans spent 22% of their budget on food. This has decreased at an average rate of approximately 0.25% per year since then. So how am I going to translate this information? In 1950, Americans spent 22% on food. Well, I'm going to say 0, 22. Why 0? Because they told us that x, this is the x value, should be the number of years after 1950. So we are in 1950, so it's x equals 0. And then instead of 22%, I just put 22, keeping in mind that I have percentage there. Then they told us that this has decreased at an average rate, so decreased, and at an average rate, it's m, and it decreased, which means minus 0.25% per year. So I chose to actually write 0.25 instead of percent because of writing 22 instead of 22%. So we eliminated the notation for percentage for both of them. So now, knowing this, we want to find out the function p of x. So p of x, it's equal to mx, so negative 0.25x, plus b, so plus 22, because they gave us the y-intercept because of the pair 0, 22. So the percentage of total spending is given by this function. P of x equals negative 0.25x plus 22. So this was problem 25. Let's discuss problem 26. In 1950, Americans spent 3% of their budget on healthcare. This has increased at an average rate of approximately 0.22%. So the in 1950, that means 0 years since then, 3%, so I'm going to put 3. And then the slope is it increases an average rate, so then it's positive 0.22. So P of x is going to be equal to mx plus b, which is 3. If I didn't have 0 here, I would have had to solve using the point slope form. Okay, now let's take a look at the second problem, the second example. The state intent of the 1994 Don't Ask, Don't Tell policy was to reduce the number of LGBTQ discharges from the military. Nearly 14,000 active duty LGBTQ service members were dismissed under the policy, which officially ended in 2011, after 18 years. The line graph shows the number of discharges under Don't Ask, Don't Tell from 1994 through 2010. Use the data displayed by the graph to solve exercises 27 through 28. So we can just take a look at the graph, right? So it's the number of discharges increases, and then it decreased between 98 and 99, and then it increased again between 99 and 2001, and then it started decreasing, increased a little bit, and then it started decreasing, right? So we'll read this graph. On the x-axis we have the year, and on the y-axis we have the number of discharged active duty service members. So in 27, we need to find the average rate of change rounded to nearest whole number from 1994 through 1998. So I'm going to write in 1994 we have 617 discharges. In 1998, there were 1,163 discharges. I read them from the graph. So when they said find the average rate of change, I need to find the slope. So it's 1,163 minus 617 over 1998 minus 1994. So let's do the math. I got 136.5, but they said rounded to a whole number, so then this is 137. Now what does this mean? It means that there is an average increase of 137 discharges per year between 1994 and 1998. Now let's take a look at problem 28. Find the average rate of change rounded to nearest whole number from 2001 through 2006. Describe what this means. So in 2001, the number of discharges was 1,273, and in 2006 was 623. Again, I read them from the graph. So the slope is equal to 623 minus 1273 over 2006 minus 2001. It's 2006. So let's do the math. And we get negative 130. So this means there is an average decrease of 130 discharges per year between 2001 and 2006. So if we take a look at the graph, yes, it makes sense. Between 1994 and 1998, it's an increase, and between 2001 and 2006, there is a decrease. I hope this helps.